myself Sanjeev Reddy. I am from Sri Venkateswara College of Engineering. Today we are going to discuss about corrosion and types of corrosion. Corrosion and its control. Corrosion and its control. Mechanism of dry and wet corrosion. Types of electrochemical corrosion. Differential aeration corrosion, galvanic corrosion, heating corrosion, waterline corrosion. Factors influencing corrosion. Protection from corrosion. Introduction. Corrosion has been defined as destructive chemical and electrochemical reaction of a metal with its environmental, which disfigures metallic products leading to reduction in their thickness and also causes losses of useful properties such as malleability, ductility, electrical conductivity, and optical refractivity. Except few metals such as gold, platinum are prone to corrosion. Typical examples of corrosions: rusting of iron due to formation of hydrated ferric oxide, tarnishing of silverwares in H2S laden hair due to formation of silver sulfide. Factors influencing corrosion. Corrosion is enhanced by presence of impurities, air and moisture, electrolytes, strains in metals like dents, scratches, etc. Mechanism or causes of corrosion. Metals are electropositive in nature, except few metals like gold, platinum. Other metals are found in nature as their compounds, which are called their ore. Metals are thus obtained by extraction from their ores by reduction process in nature. When metal exists as their compounds, they are stable and they are in low energy states. However, during extraction of metals from their ores, free metals are become less stable and are in higher energy state than in the ionic state. So metals have a tendency to back to the ionic state, and hence metal atoms are prone to get attacked by environment. This is the main reason for corrosion of metals. Types of corrosion: dry or chemical corrosion, wet or electrochemical corrosion. Types of corrosion: chemical corrosion. It involves direct chemical attack of atmospheric gases like carbon dioxide, oxygen, H2S, SO2, halogen, moisture, and inorganic acid vapors on metals. Example: tarnishing of silverware in H2S laden hair. Electrochemical corrosion. It occurs due to setting up of a large number of tiny galvanic cells in metals in presence of an impurity as well as in presence of moisture. Generally, impurity act as anode and original metal act as cathode. So anode is the area where corrosion occurs. Example: rusting of iron in moist temperature. Mechanism or causes of corrosion. Metals are electropositive in nature, except few metals like gold, platinum. Other metals are found in nature as their compounds such as oxide, hydroxide, carbonates, fluorides, sulfides, phosphates, silicates, etc., which are called their ore. Metals are thus obtained by extraction from their ores by reduction process. In nature, when metal exists as their compounds, they are stable and they are in low energy states. However, during extraction of metals from their ores, free metals are become less stable and are in higher energy state than in the ionic state. So metals have a tendency to back to the ionic state, and hence metal atoms are prone to get attacked by environment. This is the main reason for corrosion of metals. Factors influencing corrosion. Corrosion is enhanced by the presence of impurities, air and moisture, electrolytes, strains in metals like dents, scratches, etc. Corrosion has been defined as a destructive chemical and electrochemical reaction of a metal with its environmental like O2, moisture, CO2, etc., which disfigures metallic products leading to reduction in their thickness and also causes loss of useful properties such as malleability, ductility, electrical conductivity, and optical refractivity. Except few metals such as gold, platinum, called noble metal, are prone to corrosion. Typical example of corrosion: rusting of iron due to formation of hydrated ferric oxide, tarnishing of silver wires in H2S laden hair due to formation of silver sulfide. Metals are electropositive in nature, except few metals like gold, platinum, noble metal. Other metals are found in nature as their compounds such as oxide, hydroxide, carbonate, sulfides, phosphate, etc., which are called their ore. Metals are thus obtained by extraction from their host by reduction process in nature. When metal exists as their compound, they are stable and they are in low energy states. Oxidation corrosion occurs due to direct chemical reaction of atom O2 with metal surface forming metal oxide. Absence of moisture increases with increase in temperature. On exposed to atmosphere, metal gets oxidized to form metal ions. Electrons lost by metal are taken up by oxygen to form oxide ions. Nature of metal oxide layer. Types of layer. Stable layer Al, Pb, Cu, Sn. Unstable layer Ag, Au, Pt. Volatile layer Mo. Porous layer alkali metals and alkaline earth metals. Filling bed birth rule. A protective and non-porous metal oxide layer has a volume equal to or greater than volume of metal from which it is formed. A non-protective and porous metal oxide layer has a volume lesser than the volume of metal from which it is formed. Specific volume ratio. Volume of oxide formed by volume of metal occurs when a metal is contact with a moist air or any liquid medium. When two different metals are partially immersed in a solution. Chemically non-uniform surfaces of metal behave like electrochemical cells in the presence of water containing dissolved O2 and CO2. Always occurs at anodic areas. Mechanism involves oxidation, reduction process depending on their nature of corroding environment. Electrons released at anode are consumed at the cathodic area by 2s, evolution of H2, absorption of O2. Difference dry corrosion and wet corrosion occurs in the absence of moisture, occurs in the presence of conducting medium, involves direct attack of chemicals on the metal surface, involves formation of electrochemical cells, slow formation, rapid process. Corrosion products are produced at the site of corrosion. Corrosion occurs at anode but rust is deposited at cathode. Process of corrosion is uniform, depends on the size of the anodic part of the metal. Prevention of corrosion. There are many methods of protecting metals against corrosion. Barrier protection, sacrificial protection, cathodic protection, alloy formation. Barrier protection. Here, a thin barrier is developed between the surface of iron and atmosphere by one of the following methods. Painting of the surface, coating of the surface with a thin film of some non-corrosive metals like nickel, chromium and copper, etc. Coating the metal. In order to prevent corrosion, resistant coating is made between metal and environment. Different types of metallic coatings are galvanization, thin coating of Zn on iron, electroplating, coating of copper, nickel or chromium on iron with head to direct current, tin plating, coating of tin on iron, shredding. It consists of dusting of zinc powder on iron surface followed by heating, cladding, alloying the metal. Metal has better resistance to corrosion after forming alloy with other metals. Example, stainless steel, in which ordinary steel is alloyed with chromium and nickel. There are two kinds of alloys, homogeneous alloy, heterogeneous alloy. Homogeneous alloy are solid solution in which the components are completely soluble in one another. Heterogeneous alloy are mixture of two or more separate phases. The components of such alloy are not soluble and exist as separate phase. Solid solution alloys are more corrosion resistant. Silicon is also used in making SiFe alloy.